Hey dosers, welcome back to another video, and today we're going to be covering rational functions. So let's get right into it. So rational functions, they are another type of functions group, but in today's video especially we're going to be covering what are horizontal asymptotes, so HA, and vertical asymptotes, and how do you find these out, and how do they link to something we've learned in the last video, which are sine tables and domain and range. So let's get right into it. So rational functions, what are they? So the definition is given again for you over there. You can read it in your own time. You can pause the video and read it, but I'm going to explain it in a easier way as I feel like the textbook definition isn't really too understandable. So I'm just going to read it out first. Another important category of functions is rational functions, which are functions in the form of r of x is equal to f of x over g of x. So rational functions can be represented like this: f of x over g of x. This is how rational functions are represented, and f of x and g of x are polynomials. And the domain of R, that means every single possible value of x that R can have, right, is set by this, g of x. And it'll make more sense once I go into an example. So let's take an example. For example, if you have a rational function as given over here, p of x is equal to 1 over x minus 5. So the domain for p of x will be determined by this function, this x minus 5 down here especially. Why is that? So I'm pretty sure all of you know that 1 over 0, or any number, let's just take any variable, which can be any number, x over 0 is undefined. There's no value. It's not real. Yes, we cannot get a singular value for it, and it's labeled as undefined even if you try to enter it on your calculator. So that automatically means that this variable x over here, x minus 5, this can never equal to 0. So this function p of x, 1 over x minus 5, x can never be equal to 5. If x is equal to 5, you will get 1 over 0. P of x is equal to 1 over 0 if you plug in x is equal to 5. And that cannot happen. If you do that, it is undefined. So that means your domain is now limited. And your domain is limited how? Because x cannot equal to 5 for p of x, which is your rational function. And this applies for every single example that they've listed over here. So let's take q of x, yes? Q of x, so let's say q, x plus 2 over x plus 3 times by x minus 1. So the same thing applies over here. This is multiplied by each other. So if I plug in x is equal to 1, this becomes a 0. 0 times x plus 3, or whatever it is once you plug in 1, it becomes 4. 4 times 0 becomes 0, and the denominator becomes 0 again. Again, q of x is undefined. So in this case, your domain is going to be limited by 2. So x cannot equal to 1, and x cannot equal to negative 3. That is what your domain will be limited by for q of x, your rational function. So now let's move on and let's talk about reciprocal functions. So reciprocal function is a function in the form of y is equal to k over x. That means that there's no added plus 1, minus 5 like there were in all of these questions over here. There's nothing additional. There's a number at the top, and then there's a variable at the bottom. That's it. It's called a rectangular hyperbole. You don't need to know this. You don't need to know about the name. You just need to know what a reciprocal function looks like. I hope that makes sense. Now let's move on real quickly. So an example, or the most basic example of a reciprocal function is f of x is equal to 1 over x. Yes, and the graph of this is shown over here. So I'm just going to draw it out really quickly. So this is your graph of your reciprocal function 1 over x. So your graph of 1 over x is given like this. Yes? So over here, you can clearly see some sort of pattern over here. You can clearly see that there's something wrong. This doesn't seem like your normal hyperbole, even though it's called a rectangular hyperbole. And that is because of something called horizontal and vertical asymptotes. So you have a horizontal and vertical asymptote to worry about. So the easiest to understand over here is your vertical asymptote. So 1 over x, that means that you're looking for any value of x that will not give you 1 over 0. You do not want this value at all. So the only value over here that will give you that is x is equal to 0. So this is your vertical asymptote. That means that this line, let me just change color real quick. Yes, so this line over here is your vertical asymptote. So x, yes, x is equal to 0 is your vertical asymptote. That's your vertical asymptote. Now let's look at y. Yes? And like y, the vertical asymptote. Like sorry. The vertical asymptote, yes. So your horizontal asymptote. Horizontal asymptote. Let's look at the horizontal asymptote now. So your horizontal asymptote, you have to look at your graph, you have to look at your function, and you have to see which value of y is not plausible whatsoever for your graph. So this is your graph. Let's say you don't even have this. Let's say you have this. Let's say you have a million as your x value. X is equal to a million. 1 divided by a million, will that give you 0? No. No matter how big of a number you get, no matter what you plug in for x, no matter how big, it is not going to give you 0. That means that this line over here represents that this is just continuously moving along but never intersecting with the x-axis. So that means your horizontal asymptote is y is equal to 0. And that's represented by this dotted line over here. And those are your two asymptotes. So this is vertical asymptote, this is horizontal asymptote. There's one more, it's called oblique, but I will be covering that in the next video. Now let's just move on for now. So these are some rules that you need to memorize. I want you to pause the video and just look over this real quick. So it's really basic, especially this one. So for a function written in the form of y is equal to b over cx plus d plus a, yes, this is very important. The vertical asymptote is x is equal to minus d over c, because you will get an 0 at the bottom and 0 at the denominator, making it undefined. The same thing that I've explained before. And the horizontal asymptote is y is equal to a. This is because that even if this becomes 0, even if this value becomes 0, there will always be this plus a over here, and that means that you will never ever get that value. This value over here, b over cx plus d, will never ever be 0, not equal to 0. And even if you add a to that, it's going to be a greater value than a. So that means you can never obtain a in the y value. Now let's talk about y is equal to ax plus b over cx plus d. So the vertical asymptote is x is equal to minus d over c for obvious reasons, as if you plug in over here, it becomes 0, undefined value. The horizontal asymptote, this is a rule. It's a over c. So if you have a variable at the top and a variable at the bottom, it's a over c. A over c. Now this is specifically for this rule, okay? And then the last rule is for a function in the form of y is equal to ax plus b over cx squared plus dx plus e. So your horizontal asymptote, I just want to make it clear over here that it's cx squared plus dx plus e. This is a quadratic at the bottom. There's a higher order of x at the bottom than there is at the top. So the horizontal asymptote is y is equal to 0, and the vertical asymptotes are the factor once you factorize your quadratic equation. Let's say you get x plus 3 and x minus 1. Yes, that means those are the zeros of the denominator. So these will be your vertical asymptotes. So not these, but x is equal to minus 3 and x is equal to 1 will be your vertical asymptotes. I hope that makes sense. Now I have attached two questions for you to attempt. One normal question that you guys can try, but you will have to use the rules that I have attached, and one challenging question for you to attempt. And if you do not understand anything, I will be posting the link for the video that I taught how to use sine tables. So if you want, you can watch that and you can refer to that and then answer this question. And I will be posting the mark schemes on the Canva slides too, and this will also be in the description of the video. Along with this, there's a link that you can use to book a one-on-one session with me, which is completely free if you need any extra help in maths, and it's completely free. So just go ahead and do that. I hope you enjoyed the video, and I hope you understood it, and just let me know in the comments below. Thank you so much for watching. Take care. Have a good day.